Yeah, hello, ladies and gentlemen. We continue our lessons, our lessons into acid and base by today looking at pH calculation. Now we've already looked at three topics. We've looked at concentration. We've also looked at dilute solution. We have also looked at standard solution, and I believe these ones give us a good background now to move into this area. This area is supposed to be simple, and I've done my best to provide you with a lot of worksheets for you to master everything that is needed from you. Now, basically, in grade 11, you had the knowledge about pH. That gives you an idea how acidic or basic a substance is. Now, in our case, in the calculation, we define pH as the pH of an aqueous solution as the negative logarithm of the hydronium ion concentration in the solution. This is the main formula that we use. You are writing it this way or you are writing it this. But in modern science, we will normally be using this. However, any of them is accepted. So here gives you the table of your pH range, ranging from 0 to 14, right? Telling you that as you move from to your left to 0, the acidity is increasing. Whilst when you move to your right, the basicity is also increasing. Okay. Now, so this gives us a summary telling you that a neutral solution has basically a pH. The concentration is this. An acidic solution, the hydronium ion concentration is less than 1 times 10 to the power 7. Then for a base solution, your hydronium ion is less than this. That's another way of looking at it. Okay. I've done well to provide you a summary of the important formulas that you need in this area. As we saw, this is the basic formula for calculating the pH. So then 2, you are looking at the situation in this case where the you are now here you are now looking, or the pH had been given to you, and you want the hydronium or ion. In other words, the antilog of this formula, and that gives you what is here. This one appears to be much simpler. Another important formula you will apply here, we call it the auto ionization formula of water. We will explain it further, but that gives you the concentration, the product of the hydronium ion and the hydroxide ion. It gives you 1 times 10 to the power this. So if you manipulate this one in order to get your hydronium ion, you can now manipulate it this way. So this is not actually a formula, but then a manipulation from number 3. Now, alternatively, you can also solve the pH by using the POH of the negative log of the hydronium ion. That's an alternative method of solving it. Another important formula for you to understand is that the pH and the POH add up to give you 14, right? If you work it mathematically in terms of logarithm. Okay. Now, another important thing that we must also understand That is one of the common principles that you'll be using in this area, is the ionization of the acids that you'll be dealing with. And so, for instance, if I'm dealing with hydrochloric acid, what is the proportion of the hydrochloric acid to the hydronium what? Ion. So if this one now ionizes in solution, it gives you 1 mole, or in terms of concentration, it is what? 1:1. If you're looking at the ratio. You take nitric acid, it is a monoprotic, so it produces only 1 hydronium ion. So that also gives you 1:1. You look at ethanoic acid, that one also is monoprotic, and that also produces 1 hydronium ion in solution. And I believe that you understand the term monoprotic. This is not the terminology you need to explain, trying to say that it produces 1 hydrogen ion or 1 hydronium ion per molecule in solution. It produces 1 hydronium ion or hydrogen ion per molecule in solution. We come to the diprotic. In that case, we will define it as it produces 2 hydronium ion per molecule of the acid. Right. So if you now apply it here, for a diprotic, sulfuric acid produces 2. So the ratio of the concentration or the number of moles is 1:2. For a triprotic acid like phosphoric acid, you are having that this thing to be equals to what? 1:3. So you need to understand these ones. Okay. If you now come to the base, we do the same thing in order to look at the compound and the hydronium ion. For sodium hydroxide, it is 1:1. For potassium hydroxide, it's also 1:1. For calcium hydroxide, it is 1:2. And for aluminium, it's 1:3. You need to understand this one before you can do very good this. Now, so basically, if you want to do any calculation, right, first of all, you need to write down the ionization reaction for the acid, just as I've explained above. Then determine the mole ratio of the acid to the hydronium ion, again as I've explained above. Determine the hydronium ion concentration. So by the mole ratio, by the ratio, you'll be able to know the concentration. Then from there, you can now apply your formula and then you calculate. So let's quickly look at an example. So here you have, you have to calculate the pH of a hydrochloric acid solution with a concentration of 0.1. Applying your ionization formula, it gives you 1:1. So in that case, the concentration of your hydronium ion is 0.1 mole per decimeter cube. Now substituting into the equation. So you get your negative log of 0.1 and you end up getting what? 1. Simple as that. 2. Calculate the pH of sulfuric acid solution with a concentration of 0.415 mole per decimeter cube. Again, establishing your ionization, it comes down to 1:2. So if the concentration of the compound is this, then 2 times it gives you 0.83. Substituting the concentration into your formula, it gives you 0.8. Right. Okay. Now, another example. Here, you are to calculate your pH from a base. So calculate the pH of a strong base. Again, you establish the dissociation of the base, as I've explained above. Establish the mole ratio, establish the ratio of the compound and the hydroxide ions. And then from there, you do your calculation. Okay. So Take this example. Calculate the pH of a sodium hydroxide solution with a concentration this. Right. Now, so you will establish your ratio, and you find that one to be equals to 1:1. So, and that means that your hydronium anion concentration is 0.5. Now, applying your auto ionization formula of water is equals to this. Substituting into it, right? So just like I will do it over here. So from here, right? From here, you come here. So you are using this one now to find your hydronium ion. So from here, you substitute the value, then it gives you 2 times 10 to the power 14. So that's the concentration of hydronium ion. Now substituting into your formula, and make sure that you write the formula as it is, you are getting your answer. Now, alternatively, you could solve this question by applying the other method of the POH. As I said, that's an alternative thing, but you will see this one in your formula sheet, and it is also accepted. But then I will encourage you rather to be using this one. I will encourage you to be using this one. But I'm showing you all this to give you a broad knowledge, and some of the material that you'll be seeing, you also see it being applied over there. And this one sometimes appear to be very simple, but when it comes to the exam condition, I would rather encourage you with this one. Okay, we go. So now looking at your POH is equals to this, right? You've already, the concentration of your hydroxide anion is 0.5. You substitute into, you are getting 0.3. Applying your formula pH plus this equals to 14. So you now subtract your POH from the 14, and it gives your pH to be equals to this. Right. Just as this one. Okay. Now, the next one, you are looking at a situation where the pH has been given to you, and you want the hydronium ion. It could also be the hydroxide ion. So, establishing your formula. In this case, you want the concentration, and therefore become an antilog of the pH. Right. And then you substitute, you are getting your answer. But I prefer this one, I make it much simpler with this formula. That your hydronium ion is 10 to the power negative of the pH. Right? And then you substitute your value into it, you are getting your answer. So simple. 3 marks there. Okay. So you have further examples over here to do. Calculate the hydronium ion concentration of a solution with a pH of this. Establishing your formula. This is equals to this. Possibly you won't see this one. So you go straight, write this one, and then bring this one so that you get the full marks there. Substituting, you are getting your answer. The next one, the pH has been given at 3.5. Establishing your formula for a mark there. Substituting, you are getting your answer. Now, here you are now getting the reverse. Calculate the hydroxide ion concentration where the pH has been given to you. Right. So again, you can go ahead, establishing your formula, calculating the hydronium ion. Now I'm coming to use your formula for the auto ionization of water. Then you get your hydroxide ion to be this. Okay. We'll move on to a little further, where in this case you are to calculate the mass. It says a student wants to make a 10 centimeter cube sulfuric acid solution in water, of which the pH is this. Calculate the mass of sulfuric acid that is needed. Right. So Again, this one should remind you of what? Standard solution that we did. And here you are looking at, you are now moving from the hydronium ion to this, because it's asking you to calculate the mass of sulfuric what? Acid. So that gives you the reversibility of the formulas that are established above over there. That is between the hydronium ion and the compound. You must know that you must be able to work backwards. And that is the technicality of the questions. Right. So in this case, you are working your way from the hydronium to this. So you establish your formula. Using this, you are getting the concentration of the hydronium ion to be this. Right. Having done this, you here in this one, it went ahead to calculate the number of moles of the hydronium ion. Right. And then from there, he used the ratio now to find the moles, even though you could have still worked it out in terms of the concentration. And then when you finish, you work it by finding the number of moles. So now you have established that 1 mole of this is equal to 2 mole of this. Right. In that case, if now you are having 3,98 moles of this, then the number of moles of your sulfuric acid is going to be this. Now knowing the number of moles, applying your formula, N is equal to small m over big M, the mass given over the molar mass, you are getting the mass to be 0, this. There are a number of these examples over there. Okay, so that brings you into, let me say, the first part of it. Let me quickly walk you through the second part. I have divided it into 3 parts. Now, in the second part, I've already shown it to you when we were doing the dilution. Right. So, but we didn't touch the pH aspect of it. So in this case, you are looking at, in a beaker, there is 100 centimeter cube of this concentration, sodium hydroxide. The still water is now added to the solution until the volume of the solution is this. So you are saying the volume has changed from this to this. You also know the initial concentration. And therefore, by method of dilution, you should get the concentration of the final. And that is what has been established over here. Right. That's what has been established over here. So you do your applying your dilution method, you are getting the new concentration this. Now knowing the concentration of the sodium hydroxide, you can now work out your dissociation, find the ratio, right? Then you come and apply your autoionization method as has been done over here to get the hydronium ion. From your hydronium ion, you now apply the pH formula in order to get your answer. The same approach is done over here. The same approach is done over here. Okay. Now, so if you now go through, look at it. This is one of my best worksheets. My best worksheet. By the time you finish going through this one, you get to know all the technicalities. However, 18 to 21 appear to be somehow technical, so I will take it in my next video for you. Right? Here, these are some of the solutions provided. Now, another worksheet, I would like you to work this one also. Work yourself into this. Work yourself into this. So here, where the pH has been given to you, you are calculating the hydronium ion, or you are calculating the hydroxide ion. Right. You continue here by working yourself with the dilution that we did, with the dilution method that we did, right? Here provide you a number of examples for you to master it. Further worksheets, further worksheets, I will still encourage you to extend yourself, especially 3 and 4, 3, 4, 5 over in this one. Even though the memo have been provided to make it easier for you at home, right? Good. Another variety of a worksheet so that you don't get bored, right? Then I have all this long work example for you. All this long work example for you. All this long work example. There's no way that you went through this one that you will not master this area. Good. So I'll come your way in the next one. Yes, I'll come your way in the next time with a part 3, which is a bit demanding and very, very, very important in the area of acid and base. Okay, thank you.